we'll quickly now revise solving triangles. If we've got a right angle triangle, and we've got an angle on the side. Say we've got this angle here, so we know what theta is, and we know what B is. So if we know these two, that allows us to work out, firstly we can work out this other angle, and then we can use sine, cos and tan to work out the hypotenuse and the adjacent side. So there are six measurements that are in a triangle. You've got three angles, and if it's a right angle triangle, you already know one of them's a right angle, and you've got three sides. So given an angle and a side, it's possible to work out the other four measurements. So here, for instance, if we call that H and we call that A, we know that, given that we know B, and we know theta, we know sine of theta is opposite over hypotenuse, so that'll be B over H. And if we know what B is, we can then work out H. Now, we want to make H here the subject, and the quick way to do that is just to swap those two around. H equals B over sine theta. Now you can multiply both sides by H and then divide both sides by theta, and you'll get to that. But a quick way to remember that, when the unknown is down below, just switch those two around when we've got sine or cos or tan. So we've got H equals B over sine theta. Given that we know the size of B, we know the size of theta, then we can work out what H is. We can work out A by cos of theta is equal to A over H. Now, we've already worked out H from over here, so multiply both sides by H, and H cos theta would be equal to A. So we can work out A, we're given B and we're given theta, so we've worked out A and H. Now we've got 1, 2, 3, 4, 5. That's the sixth piece of measurement that we need to work out, and we know that these two angles must equal 90 degrees. So if we call that alpha, we know that alpha is equal to 90 minus theta. So that gives us our six measurements in a right angle triangle. And you can, if you're given H, you can work out A and B and so on. All right, so that's when you've got a right angle triangle. When you don't have a right angle triangle, so we'll call this A, and this B, and this C. So using the conventions from before, the sides opposite are the lower case. There is a rule, and I'm going to do it without proof. It can be proved, called the Sine Rule. And it says that A, side A over the sine of A equals the length of B over sine B equals the length of C over sine C. So what you need in this case is, if we just look at the first equation here, so given that we know, say we know the two sides and this angle, well then we can work out angle A. Or you need three of those four pieces of information to be able to work out the fourth one. And a similar type situation holds for that part of the equation. So if you're given three of those, you can work out the fourth. So that's the sine rule. The other one is the cosine rule. And these apply for non-right angled triangles. And the cosine rule goes a little bit like this. It says that a squared, so the length of a squared, equals. Now the way to remember this is we do it's a bit like Pythagoras, b squared plus c squared. So we got a, b and c, minus, it's always a minus, 2, always a 2, and then these two letters, bc, and then the cos of the angle that's opposite the side that's over here, and then that'll be angle A. So that is the cosine rule. And given, say, B and C and side A, you can work out side A. So given B and C and angle A, you can work out side A. Just extending that to the other scenarios, we've also got b squared equals, now you pick up the other two sides, so that'll be a squared plus c squared minus, now using the same pattern up here, it'll be 2ac cos the angle that's opposite side B will be angle B. And the third difference set up there is c squared equals, now what are the other two sides? A squared plus b squared minus 2ab, cos of the angle opposite side C is side C. So that's the cosine rule, also for non-right angle triangles, and given, in this case, side B, side C, and angle A, it allows you to work out the length of A. Alright, so we need to be able to solve triangles. 6 measurements in any triangle, 3 angles and 3 sides. And we can solve, if it's a right angle, we just use our sine, cos and tan, and maybe Pythagoras to work out the other measurements. And if it's a non-right angle triangle, we use either the sine rule or cosine rule, depending on the information we've got. If we've got angles and sides opposite involved, well, we use the sine rule. If we've got sides and non-included angle, or the angle that's, not opposite the sides we're given, well, then we'll use the cosine rule.